Hello everyone, my name is Yash and I'm an Enterprise Solutions Architect with AWS. And today I'm going to be talking about building intelligent applications with machine learning on AWS. So I want to start off by talking a little bit about how we got started with machine learning at Amazon. And at Amazon, we've been doing machine learning for over 10 years now. From the beginning of our history, we've always focused on this as a key area to advancing your business. And as part of that, here are a few examples. One of the things that we do is provide personalized recommendations. And think about when you're shopping on Amazon, you see all of these recommendations for items that you want to buy. These are all machine learning based recommendation algorithms that are working behind the scenes that we've been building as part of deploying machine learning solutions at Amazon. Some other examples might be with fulfillment and inventory. We use robots within our warehouse to do things like get your packages to the employees that are shipping them out. Amazon Prime Air is another example where we're using drones and powering them with artificial intelligence and computer vision to see where they're going in order to deliver some of these packages. Amazon Alexa is another example where Alexa allows you to use voice and uses the natural language processing engine that we've built based on artificial intelligence and machine learning. And another example is Amazon Go. So this is a grocery store where you can walk in, take your items, and check out without having to go to a register. You just pick up your items, and the machine learning and computer vision algorithms are tracking which items you're picking up, and you're able to check out in a kind of a frictionless experience. And so while we have lots of machine learning algorithms working on Amazon.com as part of our AWS business, one of our goals is we want to make machine learning and make it accessible to the hands of developers and data scientists all around the world. So machine learning has always been, in the past, this technology that's been only accessible to a few small groups of companies and organizations, and we want to democratize artificial intelligence and machine learning. And so to do that, we've been building out a suite of products and services for you guys to use in order to help advance your machine learning and artificial intelligence and build it into your organizations. And as a result of this, today we have over tens of thousands of active developers running machine learning on AWS. And that represents about a 250% growth year over year on our machine learning developer base. And part of this, as a result of part of this, is that today about 8 out of 10 of all machine learning workloads run on AWS. And we have customers from pretty much every industry, vertical, and segment that you can think of that are running machine learning workloads on AWS today. So this here is the Amazon machine learning stack. And these are the services and products that we provide to help you build machine learning and artificial intelligence into your applications. And I want to take a look at the stack, and it has 3 layers here, and start from the bottom and work our way up. So at the bottom layer, we have our frameworks. And what these frameworks are these are deep learning frameworks that you see used commonly out in the industry. These are frameworks such as TensorFlow, MXNet, PyTorch, and many others. And one of the nice things is that on AWS, you can run any of these frameworks. And we provide some tools to help make this easier. And one of these tools is the AWS Deep Learning AMI. So what this is this is an Amazon machine image. So when you go in and you spin up your EC2 instance, so your basic VM on the cloud, what you can do is go to the AWS Marketplace and select to launch the AWS Deep Learning AMI. And what this is it's an image where when you spin up the EC2 instance, it'll come with all of the frameworks and libraries, as well as additional frameworks and libraries that are commonly used for machine learning, pre-installed that you see on the slide here, things like TensorFlow, MXNet, and so on. And so this saves you all the configuration that you need to do in order to set all of this up, which is a lot of heavy lifting that you have to do initially in order to get started with using these frameworks. So when you launch the AWS Deep Learning AMI, you can kind of skip all of that work that you have to do in advance and get it straight to your development. Helps you get to building your models faster. Another tool that we have for helping you with running deep learning and deep learning frameworks on AWS is the Amazon EC2 P3 instances. So what these P3 instances are is they're a type of EC2 instances that are powered by some of the most powerful GPUs available in the cloud. So the GPUs that we use in the P3 instances are the NVIDIA Tesla V100 GPUs. And these GPUs give you quite a bit of performance when you use them to run your deep learning frameworks. So for example, we've found that on many cases, the P3 instances perform 14 times better in terms of training speed than the P2 instances, which was the previous generation of GPUs based EC2 instances designed for deep learning. So there are all of these frameworks that you can run on the AWS platform, but let's move up the stack now a little bit and talk about this platform layer that we have. So in the platform layer, we have two services that I've outlined here, Amazon SageMaker and Amazon Mechanical Turk. And one of the challenges that we're trying to solve with this layer over here is that machine learning is still too complicated for everyday developers. So oftentimes, developers have trouble getting started with machine learning because there's a lot of complexity to get set up. And if you look at the standard machine learning process, there's a few steps that you have to go through. First, you want to start off by collecting and preparing your training data. So you need to have an ingestion set up where you can collect this data and get it ready for machine learning. The next step is you have to decide what algorithm you're going to use for machine learning. Once you have that done, you have to have a training environment, and you have to set up and manage and operate that training environment. And then when you go ahead to go actually train your model, you might have to do it multiple times and try with different hyperparameters and train the model and tune it and adjust it to get it just right. And this can be an iterative step, and you need to have your platform ready to go in order to make that happen. Now, once you have a model that's ready, and you think is good enough to deploy into production, then you actually have to take the step in order to take that model and put it out into your live environment. And as a part of running your model up in a live environment, you need to be able to do things like scale that environment, operate it, manage it, and make sure it's running smoothly in production. And so this is where Amazon SageMaker comes in. SageMaker is a ML platform that solves all of these problems. So as part of SageMaker, we provide various solutions across all of these steps of the machine learning process. So in the first build process of machine learning, one of the things that we provide is we provide pre-built Jupyter Notebook environments that you can get up and running, and we manage those for you. So you don't have to spin up an EC2 instance and build out the notebook environment for yourself. These notebooks, you just spin them up, and they're already managed for you, and they have a lot of the frameworks and libraries pre-installed, so you can go ahead and start doing machine learning right away. Along with that, we provide a bunch of sample notebooks, and these sample notebooks show you examples of how to solve some of the more common machine learning problems to help you get started with machine learning. Additionally, as part of the build phase, what we've built into Amazon SageMaker are built-in algorithms. And these are some of the most commonly used algorithms that you see in machine learning out there. Things like PCA, factorization machines, classification and regression, image classification, XGBoost, all of these various models. And apart from those built-in algorithms, we've also provided support for some of the common frameworks out there, such as Apache MXNet or TensorFlow. And our built-in SageMaker algorithms are designed to run extremely fast. So our built-in SageMaker algorithms we've designed them for what we call nearly infinite scale. So you can throw as much data as you want into this algorithm, and what the algorithm does, all of the SageMaker built-in algorithms are distributed by default. So when you put your data into these algorithms, the data gets split into multiple nodes automatically. You don't have to worry about setting all of that up, and this allows you to train your machine learning models faster. A big component to this is that what we are able to do with our SageMaker algorithms is to train the algorithms on a single pass of the data. So this leads to faster algorithms that are tuned on for SageMaker. So when you run these algorithms using the built-in SageMaker algorithms, you'll find that typically you see much faster performance on the training side, as well as it being less expensive when you go ahead and train some of the SageMaker algorithms. Now, once we move back past the build phase and move towards the training phase, one of the nice things that SageMaker provides is it provides a training engine. So once you have your algorithm selected and you've had your data, what you can do is train in just one API call, which is what we call one-click training. So what this does is that you give the training engine where your data is, what algorithm you're going to run, and some of these parameters and initial configurations, and tell it go. And the training engine will take care of scaling the training, distributing the training, and it handles things like managing the training environment for you. So you can go ahead and quickly train your models without having to set up and manage the infrastructure behind that. Another common place where data scientists spend a lot of time in building models is hyperparameter tuning, right? So a lot of machine learning algorithms require you to tune parameters and retry training over and over again with a different set of parameters to find that model with that fits your problem accurately. So to help out with this, as part of SageMaker, we provide a hyperparameter optimization service. And what this is that instead of having to tune your hyperparameters manually, instead, hyperparameter optimization allows you to give a range of hyperparameters that you want to test within, and SageMaker automatically picks the best hyperparameters within that range for you. And this allows you to save a lot of time in tuning and testing out your hyperparameters. And once you have your model built and it's ready to go, then a really nice component of SageMaker is that you can deploy them in one click. So again, it's just one API call once your model is fully created in order to deploy it into your production environment. And the production environment is fully managed. You don't have to worry about the infrastructure. The SageMaker platform takes care of that. And it comes with features such as auto-scaling and monitoring and logging, so you can know what's going on in your training environment, as well as keeping it scaled and ready to take on production traffic. So when it comes to SageMaker training, there's really three components that I'd like to think about it in. There's first, you always have the option to bring your own algorithm. So if you're using a custom algorithm, you can wrap it up and package it so that it can run on Amazon SageMaker and allow you to take the advantage of some of the benefits like the managed training platform and the managed hosting platform when you're using SageMaker. The next component is we have pre-built wrappers around the libraries TensorFlow and MXNet. So if you're using these libraries, it's pretty straightforward to supply your code to SageMaker, and SageMaker can take care of doing things like distributing and scaling the training jobs, and then automatically deploying the models into production with just one API call once you've built out your TensorFlow and MXNet models. And then finally, we have the built-in SageMaker algorithms. So these are the algorithms that are designed to run faster on SageMaker than most likely anywhere else you'll see. And so when we were talking to customers about SageMaker, one of the questions that they often asked is, how can we make our own algorithms that we've brought to the platform as fast as those on SageMaker? And so very recently, we've announced a new feature for Amazon SageMaker, which is SageMaker streaming for custom algorithms. And so what this allows you to do is, when you're bringing your own algorithms onto Amazon SageMaker, what you can do is stream the data into the SageMaker training engine. And this allows you to train with much faster speed. So oftentimes, what you have is you have some data that's saved in S3, in your S3 buckets, and you want to bring that data onto your training platform. So what the SageMaker streaming for custom algorithms allows you to do is to stream that data onto the training platform instead of having to download all of it at once and then go ahead and start training. And this allows you to train your algorithms significantly faster. Today it's available for TensorFlow algorithms, and it'll be available for additional frameworks very shortly. And once you're done with the training side of things, then you have to go on and host the algorithms into production. So in the hosting side, we provide a bunch of features to help you host your algorithms faster. For example, you can deploy onto one click using one API call, and then it comes with features such as A/B testing. So if you want to deploy various versions of a model and decide which model is better, you can deploy multiple models out to production, assign them different weights, and test them, and send a different amount of traffic to different models and see which model is the better performing model. So the hosting platform comes with a bunch of advanced functionality in order for you to advance your machine learning hosting. So the machine learning hosting comes with an API endpoint. So this is an HTTP endpoint that you can make calls against. And when you make these calls, it comes back with your prediction results from your model and algorithm. And you can set up things like auto-scaling on these endpoints so that behind the scenes, the infrastructure scales for you automatically. So if you have a high request rate, you don't have to worry about that. You can auto-scale in order to meet that high request rate. They're low latency, so you'll find that they're high performing, and they're spread across multiple AZs. So you'll have a high availability design by having the algorithms run, or the hosting run on multiple availability zones. One of the common questions that customers had around hosting was that, what if you have giant files that you want to run predictions on, and you want to do this in a batch process instead of a real-time API? And so in order to answer these questions for our customers, we've come out with a new feature for Amazon SageMaker called Amazon SageMaker Batch Transform. And what this allows you to do is it allows you to create inferences and do high throughput batch jobs. So you can process inferences for large files very easily in a batch manner against the SageMaker hosting environment. And so Amazon SageMaker is an end-to-end ML solution, ML platform to help you build, train, and deploy your machine learning algorithms. As we move up to the top of the stack, here we have our application services. Our application services are API-level services. So these services allow you to integrate machine learning and artificial intelligence into your applications without having to understand the complexity of machine learning and deep learning technologies. And so the way they work is you make API calls to these services within your application, and they provide some sort of machine learning based answer back from the APIs. For example, recognition is one of our computer vision based services. And you can do things like give recognition an image and get back metadata about what is in the image. So I want to go through a few examples of what customers are building with these API services in order for you to understand how they're used and what they do. So one use case that we see commonly out there in the industry is improving contact center with some of our API services and machine learning and artificial intelligence. So a lot of organizations have large contact centers that they're running, and we have a solution called Amazon Connect that allows you to run these contact centers in the cloud. And one of the nice things that you can do with contact centers in order to improve their efficiency and get better customer service is to integrate it with some of our artificial intelligence services. So one example is you can have a solution here where you have Amazon Connect helping you run the contact center in the cloud, and have that using Lex as well. Amazon Lex is our automatic speech recognition and natural language processing based chatbot service. So you can use Lex with Connect to create voice-based chatbots that your call center users can interact with. And this lets you help automatically resolve some of the contact center issues. But Lex isn't the only AI service that you can use as part of this suite of the solution. Another service that you can use is Amazon Transcribe. So when the contact center calls come in, what Amazon Transcribe allows you to do is create a transcription of the conversation that happened. So you can convert that voice interface into text. And recently we've announced a new feature in Amazon Transcribe called channel synthesis, which allows you to use multiple channels and have multiple streams of audio and still understand what is going on in multiple channels of audio. So once you have the transcription in text of what the call is about, then you can move on and transfer that data into Amazon Comprehend. And Amazon Comprehend is another artificial intelligence powered service that lets you do natural language processing and understand the meaning of the text. So with the transcript, when you give it to Amazon Comprehend, you can do things like figure out what's going on within that text. So you can identify things like the sentiment of the text. You can identify things like what are the key phrases that were being talked about within the conversation. And recently, we've now support syntax identification, where you can identify things like nouns and verbs within the text as well. And this all can ultimately power the analytics of your contact center, and you can trace the health of your contact center through artificial intelligence-based analytics using the solution and these suites of API services kind of strung together. I have one more example of these API services at work here. And so this is an example where we want to track kind of the sentiment and what our customers are saying about our business through social media and our support channels. So we can see what's going on and what customers are thinking about our business. So here what we have is a flow where we're collecting data from social media and support, and one of the things that we can do is put it into Amazon Translate. And so Translate is a translation service which allows you to translate information across various language pairs. And so if you have social media data or support data in various different languages, but you want to understand it in one language, you can use Amazon Translate in order to translate that data onto into one language. From there, you can then transfer that data again to Amazon Comprehend, which is our natural language processing service, and then go ahead and understand things like the sentiment of what is being said about our business, or what are the key phrases being said about our support offering. We can then take that information, dump it to Amazon S3, which is our storage layer, and do things like perform queries against that data, or build dashboards to see things like the sentiment of business over time, and do all sorts of analytics around what's being said about our business through the social media and support channels. So with that being said, I want to transition into a demo of Amazon SageMaker, which is our end-to-end platform service for quickly building, training, and deploying machine learning models. So over here, I have the AWS console opened up, and what I'm going to do is go to Amazon SageMaker. And this here is the main SageMaker console. So over here, you'll see that we have kind of the main flow of SageMaker, where we have our notebook instances, our training jobs, and our hosting or our inference setup. So what I want to do first is to show you the notebook instances. And I'm going to show you a demo of what it's like to create a new notebook instance to get started with Amazon SageMaker. So what you want to do is go ahead and give your notebook instance a name. What you then can do is select an instance type for the notebook. So depending on how much data or what you want to do within this notebook, you can select an instance size that's appropriate for your notebook. So this corresponds to how much things like memory and CPU are going to be available on this hosted Jupyter Notebook environment. The next thing that you have to do is select your IAM role. So the IAM role is what allows you to allows SageMaker to give permission to do things like access your data in S3 and run SageMaker training jobs on top of it. And then we have some additional optional configurations, like if you have databases in VPC, like Amazon Redshift, you can select a VPC here to connect your SageMaker notebook into. We have a lifecycle configuration option, which allows you to set up some sort of startup and default scripts that when you want to start up your Jupyter notebook, your notebook instance here, you can run that script and install any additional libraries or anything else you might need in order to do your work on the notebook instance. And we also support encryption using Amazon KMS or Key Management Service, and this allows you to encrypt the data on your notebook itself. So I'm going to go ahead and click Create Notebook at this point, which just goes ahead and starts creating a notebook in my environment, and you can see that this is this demo notebook here that is now pending. So this takes a few minutes to start up. In the meantime, I have some other notebooks that are ready to go and in service, so I want to show you what it looks like to start one of these up. So what I'm going to do here is click Open, and when I open it up, what happens is in a new tab we get a demo environment, a Jupyter Notebook environment where we can do a demo of SageMaker in action. And so as part of SageMaker notebooks, we provide a bunch of sample notebooks that come built into SageMaker, and these are really good to help you get started with anything in SageMaker. If you want to learn more about machine learning in general, there are some great examples in here on how to apply machine learning, as well as if you want to learn any of the SageMaker algorithms and how they work. There's examples in code of how you can use the Amazon algorithms, as well as some of the more advanced functionality, like bringing your own custom algorithms onto SageMaker. You can find examples of these through these samples notebooks. So what I'm going to do is I'm going to switch to a notebook that I've already had open, and in the sample notebook section, we have in the Intro to Applying Machine Learning folder, an example around customer churn and detecting customer churn. So I'm going to open this up and go through it to give you a sense of how SageMaker works. And so what we're doing in this example is we're detecting customer churn with a model called XGBoost. And if you're not familiar with XGBoost, it's a machine learning algorithm that comes pre-built into SageMaker, and this algorithm is really good at solving a few machine learning problems, including classification, which is what we're doing here. And so this example is what's called customer churn. So here what we're doing is trying to determine churn, which is whether or not one of our customers is going to leave our service. So I'll go through the example in code, and this is available for you to try out yourself if you want to, following the same steps that I did here with using the SageMaker sample notebooks. And so you can read through some of the description in the notebook if you want on your own time, but for now I'm going to go through the code and show you how it works. So the first step we do here is we define some of the prerequisites for our notebook, which is the S3 bucket that we're going to have our data in. So when we're using SageMaker, our data resides in S3, and then it comes down to the training platform for training. And so over here, this is the name of the bucket that I'm using, and the prefix of where I'm going to be storing the bucket. Over here, we're also getting the IAM role for SageMaker through our training environment, through our notebook environment. So this is the first step, and in the next step, what we're doing here is we're importing a lot of the libraries that we will need in order to run this notebook. The next step here is what we're doing here is downloading the data that we need. So this is using one of the data sets available on customer churn. And let's take a look at the data set here. This is the data set itself. And so what the data set is saying is this is the data of a telecom customer, a telecom company. And this telecom company has data on their customers and when they churned in the past. So with that data, we want to predict when customers are going to churn in the future. So if you look at the data here, we have multiple rows, and each row represents one customer, and we have certain attributes about the customer, like what state they lived in, things like do they have voicemail, how many minutes that they call during the day on their cell phone or whatever phone they're using, how many minutes they used in the night, etc., etc. But one really important column here is the last column, which is the churn column. And the churn column is a binary value, either true or false, and it's showing you whether or not this customer churned. So here's an example where a customer actually churned, meaning they left our service. So what we want to do is, with this model, is to determine, given these attributes about these people, can we predict whether or not a customer is going to churn in the future? And if we're able to do that, we can do things like send them a promotional email or send them some sort of content to help them stay on the service. So one of the first steps that we want to do in machine learning is to explore our data, and this is what we're doing here. So over here, what we're doing is taking a look at some of the distributions across how many people were across each of the attributes. So for example here, we're saying here that based on every state, how many people were in each state, and we see that about 1% or 2% of people are from each state. So over here, what we're really doing is looking for any really skewed distributions. For example, if 50% of the people in this data set were from one state, we would have to account for that because that might skew the results of the model, but it seems like that's not the case here. And we do this for all of our features. And we examine this data set, and one of the first things that we realize is that some of these values probably don't provide any meaning to our machine learning model. For example, a phone number probably has no correlation to a person churning. And so what we do is we do things like do a little bit of feature massaging and feature engineering where we just drop that column. Another transformation that we're doing here is we have one of the columns in our data set is area code. And one of the things about the area code is that the area code is a number. But if we think about it, we don't want to actually represent area code as a number because area code really represents a category. And so one of the things that we do here in the next line of code, besides dropping the phone column, is that we convert the area code from an integer or from a number into an object. And so this now represents a categorical value instead of a numerical one. Over here, we're doing some more analytics, and we're looking at the correlation between all our attributes and whether or not they churned or not, to see if there's any obvious outliers. So for example, if all of the people who churned were from a particular state, this would reveal itself through this kind of analysis. As we keep going through some of the analytics here, we look at the distribution of all of the features that we have in our data set in relation to one another to see if there's any correlation between any of the attributes and each other. And in just a minute here, we'll load a graph of that. And so indeed, we see that some of our attributes are pretty much exactly correlated with each other. And so one of the things that we want to do is we want to drop some of these values that are essentially 100% correlated to each other, because it may end up messing up a machine learning model. This really depends on what model you're using. And depending on what model you're using, this may affect some models significantly and other models just a little bit. But it's a good idea to drop some of these values because they're exactly correlated to each other. So by adding these values multiple times, it's like we're adding them twice and giving them double weight instead of having them just once in there. So we're dropping columns such as day charge, eve charge, night charge, and international charge, because you see there, these are the columns that have direct correlations to one another. And so now that we've done all of this data massaging, we're done with this initial step of playing with their data. And when you're building your machine learning models, this step might take multiple iterations, and you might have to play with the data a lot and try different things to get a good result. This is standard in the machine learning process, but in this case, we're going to go ahead and continue. And so one of the final steps that we have to do here is, as part of the XGBoost SageMaker algorithms, one of the things that we want to do is to put our data into the right format before it's ready for training. So here we're putting the data into a CSV format. And the way the format works is that the first column in our CSV represents the target value. And in this case, our target value is churn. So the first column is going to be a number, binary, 1 or 0, that's going to represent whether or not the customer churned. And then we can have the rest of our features as part of other columns in the CSV. So we set that up here. The other thing that we're doing here is converting categorical features into numeric features. So we have certain categories like churn, where the value is something like true or false, and we want to turn that into 1 or 0. So we do that as well. And then finally, once our data is ready, what we're doing in our next step is uploading our data to S3. So over here, we're splitting our data up into the kind of standard training, validation, and test data set. So we have 3 different data sets that we have split our data into. And now we have the training data and the validation data as CSV files uploaded into S3. So once we have that, we're ready to go ahead and train our algorithm. So this is where some of the cool elements of SageMaker comes in, where we can go ahead and actually use the SageMaker training. So over here, we've defined the containers for XGBoost training for SageMaker across the various regions. So these are global container IDs, so everyone will use the same container. There's one per region. And then we get pointers to where we've saved our data in S3, and we're ready to go in terms of setting up our training. So this is all it takes in terms of code in order to set up the training itself. We create a SageMaker session object here. And then with that, we create a SageMaker estimator. And the estimator is telling us what model we're using. So this container dictionary that we have up here shows us what is the container that we're going to use. And in this case, it's the XGBoost container for the region that we're in. We give it the IAM role, which gives us permission to get our data from S3. We have then one of the coolest parts of SageMaker is we can set up the auto distributed training. So over here, we select how many instances we want to run on and what instance type we want to use. And the cool thing is you can change this number to be more than 1, so you can choose to run on 2, 3, 4 instances and whatnot. And SageMaker will automatically take care of taking your data and distributing it across multiple training nodes in order to get faster training. And this helps you scale for large data sets really quickly. And then we tell SageMaker where we want to output the data in S3 once it's done, or output the model, and we give it the session object that we created here. Once we do that, we set up our hyperparameter. So the XGBoost algorithm has certain hyperparameters, and we've put in some values here that that we've tested for this model, and we know they'll work for demo purposes. But in reality, you might have to spend some time tuning the hyperparameters here. And this is where you can look into the hyperparameter optimization if you want, in order to help you tune those automatically and in a much quicker way instead of manually testing them out. And then finally, we can call our fit function, and this goes ahead and starts the training job. So the training actually takes a few minutes to run. So instead of doing the training in real time, I will show you the result of what happens once the training is created, which is that you get the training log over here. So if you look at the result of this training job, you'll see we have our training log. And you can see things like we have multiple rounds of training going on here. And with each round, we have our training error and our validation error. So this is telling you the accuracy of our model over time as we go through multiple rounds. And you'll see as we go through more rounds, our training is going down as we go through multiple rounds. And over here, towards the end, we get to a lower training error that we started from. So once our training job is complete, then we can deploy to production. And again, it's one API call in order to deploy our model into production. So we just call xgb.deploy. And again, we give it what instances that we're going to run on our hosting platform here and how many we want to start with. And that's all it takes. You run this and your model is taken from training into production. And again, this takes a few minutes to run, so I've already done this in advance. So I'm going to go on to the next step, which shows you once the model is trained and deployed, how do you actually make predictions? So to make our predictions, we had our test data that we had separated out, and that's what we're going to use in order to make our prediction. So what we're doing here is converting our text data into CSVs using a CSV serializer. And so their data is in the right format, in the CSV format we trained it in order to do the predictions. And over here, we've built our own prediction function. So this prediction function does a bunch of batch predictions. So in our training data, we're taking 500 predictions at a time and running them all at once. So over here, we do some manipulation of the data itself to get into the proper CSV format. And then the real prediction call is right here in the code. If you see xgbpredictor.predict, this is going ahead and actually calling the SageMaker endpoint, which behind the scenes is an HTTP endpoint that you're making an HTTP request to, and it's giving you the results of the predictions. So we're doing this in a loop for all of the batches that we have at once, and when we run this, here are the outputs. So this is an array with all the batch predictions that we're making. And so what this is saying is that the first person in our data set, the probability that they might churn might be like 0.1. The second person might be 0.1 again, 0.105, and so on. So you'll see some of them will have higher probabilities than others. So for example, we have a 0.78 here, and this customer is probably more likely to churn, and that's the result of our model. So what do we do with these raw predictions? Well, the next step what we can do is set up a threshold. So we can say, at 0.5, let's say anything above 0.5 is predicting that our customers will churn, and less than 0.5 will predict that they're not churned. So you can play around with the threshold and test out, what is the right threshold for you, and that's a matter of trial and error in order to figure out the best threshold. And with that, you kind of have a model that's ready to go, that's able to predict whether or not a customer is going to churn from your service. So this is one example of an end-to-end flow for creating an Amazon SageMaker model, downloading the data set, massaging it, training the data, deploying it, and then making predictions. So once we're done with that, we can go ahead and delete the endpoint to clean it up. And that concludes this demo. Thank you for joining today's webinar on building intelligent applications with machine learning on AWS. We've covered a lot of topics today. We've looked at the various services available on AWS in order to build machine learning applications on AWS. We've looked at the frameworks like the deep learning platforms like TensorFlow, MXNet, and how we can build them and run them on AWS through using things like the AWS Deep Learning AMI, but we can also use them on our platform services like Amazon SageMaker. We also looked at our application level services like Amazon Comprehend and Amazon Translate to show you how you can use them together as part of a solution that powers your business on AWS. We also did a demo of SageMaker, and SageMaker is this end-to-end platform that allows you to build, train, and deploy these machine learning models. So if you want to get started on machine learning, one of the nice places to start, depending on your use cases, could be anywhere between the API level services to the deep learning frameworks to Amazon SageMaker. One of the places I'd recommend to get started is to open up a SageMaker notebook instance and look at the sample notebooks. There are great notebooks out there, like the one we went into, along with additional examples with how to get started with machine learning. Thank you for joining the webinar.